On the coast of the Arabian Gulf, east of Saudi Arabia, 90 kilometers north of Jubail city, the industrial city Ras Al Khair was established at a total cost of about 120 billion Saudi riyals. The establishment of the city was due to the kingdom's development and progress plan to diversify sources of income in order to be liberated from relying on petroleum, which represents 90% of the kingdom's exports. Therefore, it was necessary to establish a port for the city to be the main artery for mining exports that are estimated by 4,335 million tons, on top of which are phosphate and aluminum. It's expected that their revenues will reach 97 billion Saudi riyals by the year 2020. Also, the volume of imports that are received by the port are estimated at about 660,000 tons. Therefore, it was decided to establish Ras Al Khair port along a navigation canal with a total length of 24 kilometers and with a cost of 3 billion Saudi riyals. So it is ranked the third biggest port in the kingdom after Jubail and Yanbu ports. In 2013, the Saudi General Authority for Ports assigned EDEX branch in the kingdom as a leading and pioneering company specialized in marine constructions, and by joint venture with the Saudi company Rawabi specialized contracting to establish the two container berths 9 and 10. In addition to the completion of berth 8 with total length of 835 meters, after the distinguished offer that the two companies presented. The cost of the project reached 284 million Saudi riyals. The project was scheduled to be implemented within 30 months from July 2014 to December 2016. The first step was making offshore soil investigation, land surveys, and bathymetric surveys for the site. It was followed by the design works, which were reviewed by one of the world's major specialized experts, COE. Then it was approved by the General Authority of Saudi Ports. The project started by dredging works, which were divided into basin dredging up to 16.50 meters below sea level. In this phase, the dredger Osman II was used with its potential to dredge 20 meters depth at a rate of 7,000 cubic meters a day and with an ejection line up to 2,000 meters. Then the dredging of the foundation trenches to 26 meter depth below the sea level. The volume of the dredging output was 3.5 million cubic meters of sand, which were stored in the area, of which 1.5 million cubic meters were used for the reclamation of the low areas of the port, and 2 million cubic meters for reclamation behind the berths in the different stages of the project. During the dredging process, the establishment of the berth of barges that will undertake the marine works started by creating metal curtains that allow the barges to dock in front of it with 40 meters depth. These curtains were fixed with steel props and cement barrier belt behind them. The area above was paved to be used in the transport of blocks and rocks to the barges using ground crane with a capacity of 500 tons. 5 barges and 3 boats were used in the project. Each barge capacity carried 13 blocks with total load up to 1,700 tons per trip. Before starting the works, a graphic preview for the existing port of the berth number 8 was carried out by divers. Also, the old blocks were identified and lifted. Besides, divers determined the places where the new blocks would land to complete the berth. The formation of replacement layer process for berths number 9 and 10 started by the replacement of dredging output instead of the soil under the foundation of a layer through digging deep trenches and filling them with a layered sand from dredging output. Then the vibrio compaction, where the high-pressure water was used to compact the reclamation sand. Then the stone layer was put on the sand layer to ensure the proper distribution of berth loads for the soil, then the leveling layer of the smaller rocks. The drilling output, the foundation and leveling rocks process were made by using a barge which base can be opened when it reaches the targeted area to drop the load. Then the divers leveled the rocks using iron rods and measuring the tilting degrees of the sea level to be able to bear the massive weights of the blocks. According to the nature of the soil in the region, the block system was chosen. The system depends on compacting very large blocks of concrete, one on top of the other, and without using mortar, but by overlapping to form massive and heavy architectural construction to bear the heavy weights for equipment, cranes and goods. During the first phase of the dredging process, ready-made concrete manufacturing station was established at the same time on an area of 36,000 square meters, which is sufficient for the installation and processing of 140 blocks. During the work in the station, 35 models of forms according to the dimensions and the function of the block and its location from the berth were used. Wooden forms were used to make special blocks to complete berth number 8. Also, metal forms were used to make the rest of the blocks. However, they are different in the size of iron reinforcements, so the upper and lower blocks and the cupping beam blocks were fully reinforced, where the rest of the blocks were reinforced by light reinforcement. Then the concrete was poured into the form. The work was proceeding around the clock to provide the project-required blocks, which amounted to about 5,000 blocks with weights up to 130 tons and dimensions up to 15.75 meter long, 2 meter wide, and 2 meters high. An accurate system was developed for arranging the casting of the blocks so as to ensure that every block at the exact time will be in its final place in the berth. Also, for ensuring the quality of the concrete, many tests were conducted to measure the quality and specifications during the casting process, as well as a suitable period from the casting process that allows the concrete gaining enough resistance. The blocks are processed to ensure the stability of concrete quality. As it was necessary to pour the blocks according to their needs, it was necessary to store them in the same order to save time. So a yard was prepared to store blocks at 36,000 square meters in order to store 400 blocks on 3 levels. 6 cranes were used to lift the blocks and store them with a lifting capacity of 300 tons. 2 low-level transport sweepers were able to transfer loads up to 150 tons to transport the blocks from the yard to the barge's quay. Then the barges moved the blocks to their loading places through floating cranes with a capacity of 200 tons, which landed them according to the directions of the divers, who determined accurately up to 2 centimeters the place of every block and for a distance of 835 meters and 18 meters depth from the seabed. The blocks were then stacked on top of each other to the water surface with a slight vertical inclination backward to the land in order to compensate the reverse inclination forward towards the sea, which is expected to occur after the reclamation behind the blocks and loading experiments. The reclamation process behind the blocks also started coinciding with the dredging process, where layers of rocks of different sizes were placed atop of them, the industrial fabric or geotextile. These operations took place with the help of divers to make sure that the surface of the soil was leveled and the geotextile was stretching over it. Then the geotextile was reclaimed by sand from the dredging output and by using bulldozers and loaders until the level of reclamation reaches the same level of the arranged blocks. After the blocks were arranged, constituting the barrier for the berth, loading tests were conducted through placing heavyweight loads of blocks to investigate and ensure the design requirements. This is followed by establishing the main prefabricated coping beam above the barrier. So the front part consists of blocks with specific concrete shapes that were produced by the ready-made concrete plant. The back part was poured in the site to meet the reclamation process behind the berth, which has been completed until it reached the specific level. Taking into consideration during the establishment of the coupling beam, the places for extending all the pipes and cables for utilities, services and trenches, in addition to the installation of bollards, ladders and ship fenders. In the final phase, rocks were placed in front of the quay wall to protect the quay wall from scoring and without affecting the specific depth level of the berth or basin. ADEX has harnessed all the success factors for this giant project by providing 2 ready-made concrete mixers that produce 200,000 cubic meters of concrete for all the phases of the project. Also, a huge workshop was equipped for manufacturing and the formation of the reinforced steel and installing in the various forms that were specifically manufactured and in different models according to each model of blocks. So about 3,600 tons of epoxy-coated steel reinforcements were formed, in addition to supplying and using 530,000 tons of grated-sized rocks for backfilling works behind the quay wall. All these figures reflected the huge workload and exerted efforts in a short period of time. The results were impressive when the port was inaugurated in 2016. It was appreciated and praised by senior officials in Saudi Arabia on the business level, which placed the port on the same equal footing with international ports. ADEX, our speedy performance and building strength.